Welcome to Masterminds 2022. I'm John Anderson. I'm a member of the University of Victoria Retirees Association. To begin, and on behalf of Masterminds and this evening's presenter, I want to acknowledge the Lekwungen-speaking peoples on whose territories, unceded territories, the University of Victoria stands, and the Wixanish, Songhees, and Esquimalt peoples with whom we share this very special place on Earth. The Masterminds series is an initiative to foster community university engagement by providing very high quality lectures on topics of significance and general interest. The series has been going on now for over 15 years and has had over 60 very thoughtful and thought-provoking presentations over that time. This evening's will certainly be no exception to that. The Mastermind series is comprised of 4 lectures on each Wednesday evening in April. Each lecture is created and delivered by a University of Victoria retiree in his or her field of expertise and is of general interest and importance. Each year, the series is developed by a collaboration of the University of Victoria Retirees Association and the Institute on Aging and Lifelong Health. And I have to recognize the pivotal role played by Leah Potter of the Institute in organizing and actually delivering these lectures, particularly on the, now we're into the Zoom format. And before we begin this evening's presentation, just a word or two about the Zoom format. As audience members, your audio is muted, and questions are taken. If you go to the bottom of your screen, just to the right of center, there's a little tab that has Q&A. At any time during the presentation, just click on that, and you can type in a question that will be addressed at the end of the presentation. In addition, the event is being recorded and will be posted on YouTube and uploaded onto the websites of both the Institute on Aging and Lifelong Health and the Retirees Association. So, on to the presentation. And this evening's mastermind is Professor Emeritus David Docherty of the School of Exercise Science, Physical, and Health Education. David's taught human anatomy and exercise physiology at UVic for 40 years. His research was primarily on the effects of resistance training on neuromuscular adaptation, as well as the physiological demands of physically demanding occupations. One of those, I remember, was firefighters. His most recent research articles, according to ResearchGate, have garnered over 60,000 reads and citations. In addition to being a scholar, he was both a player and later a coach in Canada's national rugby program. And in 2014, he was inducted into the UVic Sports Hall of Fame. He is a member of the UVic Speakers Bureau, a popular presenter on topics related to physical activity, health, and wellness for all ages. And he combines his knowledge in exercise science and practical experience in teaching fitness classes, often targeted at older men. So this evening's presenter, with no further ado, David Docherty.
Thanks very much, John. Good evening, everybody. Thank you for joining us tonight. Yeah, I think you probably know the topic of the presentation this evening. It's going to be talking about the brain and how physical activity can help and enhance the brain, particularly as we get older. So I'm going to go straight into my PowerPoint presentation. And in order to do that, I just need to go into share screen. Need to make sure the sound and things are turned on. This is not the first slide, but I will pull up the first slide once we're there. Okay. Now, let me go back on this. Not a good start. Okay. Okay, let me try that again. This is a classic Zoom. Things always go a bit astray. So let me try it again. Okay, that's the one I want, and I'll just get rid of this gray strip in your middle of your screen, and hopefully now we've got full screen and the gray little strip in the middle will disappear fairly shortly. So yeah, so there's the title of the evening's presentation. It's called Boosting and Maintaining Brain Power as We Age. And I'm going to share with you a little headline that appeared in the paper a few years ago about talking about this as being as easy as a walk in the park. So as John said, I'm a professor emeritus in the School of Exercise Science, Physical and Health Education. I retired quite a few years ago now. Okay, so the outline of my presentation, I'm going to share a few statistics, in fact, just one slide. And after that, I think in order to understand the effect of a physical activity on the brain, we need to know a little bit about the brain and how it works, and particularly related to the cells that make up the brain that we refer to as neurons, and then how physical activity has an effect on the way the brain actually works, both in a kind of short term and then in a long term. What in the exercise field we talk about acute responses and chronic responses or permanent changes. And then I'll talk a little bit about the types of physical activities that have been used in research to show some improvements or some maintenance of cognitive ability and memory as we age. So that's the plan of attack, and hopefully we'll have time at the end for you to ask questions. Now, I said I'd share with you a little bit of data, and this I've kind of extracted from a number of different sources, but one of the issues related to an aging demographic in Canada and the rest of the world is obviously some of the diseases that become more prevalent as we age. And certainly there are diseases of the brain that are likely to occur as we get older. And it's been estimated that over 4 million Canadians will eventually suffer some kind of brain issue or challenge or disease of the brain. It's not always dementia, but other forms. And this is going to be an incredible cost to our healthcare system. And, dementia alone, they estimate costs about 10.4 billion a year annually. Because obviously, if these diseases are contracted, they're often chronic and they're often degenerative, and they require very long-term support from both family caregivers and, of course, our health system. So as we look ahead in Canada, right now there are over 500,000, that's 7.1% of our population over 65, living with some form of dementia. And that number is predicted to, of course, rise as that age demographic increases up to 2030. And there are a number of new cases diagnosed each year. In addition to things like dementia, there are also other degenerative diseases of the brain, such as Parkinson's. And again, that is a number that's likely to increase in that condition. It seems to be more common in men than in women. However, there is also an incidence that is in women that is more than men, and that is the case of dementia. And in addition to some of those degenerative diseases, there's also a lot of people throughout life, but particularly as we age, that suffer from depression, anxiety, and stress. And we can look at some of the data that suggests that physical activity may in fact have a positive impact on all these kinds of conditions. So that's a little bit of background of saying, we're facing a challenge. And I think as we age, there's a couple of things that we probably want and we kind of set as personal goals, and that is to not be a burden on other people as we get older and not to be a burden on the healthcare system. So anything that we can do that diminishes the chances of that happening, I think are in our best interests as well as in the interests of our loved ones and society in general. Now, there's a term that's been tossed around a lot in recent years, and it's referred to as brain plasticity. And certainly there was up to a time, maybe 15 years ago, when we generally thought that the brain was pretty static, and as we aged, what happened was that cells died off and our brain function would decrease as a result of the aging process. However, there's been a lot of research that's shown that the brain is very adaptable and can in fact adapt right through old age and into very old age. And there are things that we can do to enhance that adaptation. So that's generally been called brain plasticity. It became apparent really when people had strokes. And as you know, in a stroke, part of the brain loses blood supply, and as a consequence, that area of the brain dies off, and therefore that functional part of the brain is no longer effective. But they found that the brain is adaptable, and other parts of the brain can in fact take up that function that has been lost. So, that function will shift to a different part of the brain because the original part of the brain is no longer working very well. So that's when people really got interested in this idea that, boy, the brain is adaptable, and how long does that go on, and can we take advantage of it? So that's what we're kind of looking at here. So that's one term that I'll throw out. There's another term that's going to come out throughout this presentation. You've probably heard it with other presenters who've talked on a similar theme, and that's referred to as neurogenesis. Of course, neuro is referring to nerve, and genesis is the birth of. So this is a concept that's come up in probably the last 15 or so years that suggests that, we can generate new nerve cells, and this kind of thing can go on. And in addition to that, what we can do is to help these cells in the brain talk to each other much more effectively. Now, what I've got on the right hand here is basically a typical nerve cell in the brain. And this is the main part of the nerve, and you can see from the nerve, it has a number of these thread-like structures going out and to it. So some of these threads are going away from that cell, and some of them are coming towards it. And right in the middle, you can actually see the cell nucleus. And you can see these bright red marks here, which kind of imply that there's electrical charges that are coming into and out of this particular cell as it connects and joins other cells within the brain. And that, to me, is one of the ways in which the nerves actually connect and the neurons connect with each other through these electrical conductions. It's an electrical impulse that travels down these fibers and connects with other nerve cells around it, and sometimes quite a long way away from it. So these are the strands that go out and help that connection. Now, again, another type of statistic that's thrown out is that, within the brain, it's estimated that there are something like 100 billion of these neurons or nerve cells in the brain. And again, what is kind of interesting about the brain is that these cells obviously don't function in isolation. They have to function with a very close connection with all the other cells that are in the brain in order to make things happen or not happen. So there's a lot of excitation that goes on, but there's also other cells that dampen things down. So this kind of interconnection between the cells is super important. And it's estimated that one nerve cell is actually connecting with 40 to 50,000 other nerve cells. So that's kind of, this massive complication that's taking place. Even now, as you're sitting there, all those 100 billion cells, not all of them will be working, but a lot of them will be. And if they are, then they're connecting to lots of other cells within your brain. And I thought I'd take a little aside here and talk a little bit about how these neurons work, because I think it's kind of important in regard to how we can impact these neurons and what they look like in regard to as we age, and particularly the kind of impact that physical activity can have on these particular neurons in the brain. Now, there are many neurons in the brain, and the ones that are really most active are kind of located either in the outside of the brain, which we call the cortex, which isn't very thick. So a lot of the cell bodies are in fact located there. Then we have other cell bodies that are located in pockets throughout the brain that we refer to as nuclei, and I'll talk a little bit more about those later. But remember, I said that these cells have to connect and communicate with other cells. So this would be a typical nerve cell that may be in the cortex, or it may be in one of the nuclei within the brain. And this is the body of it. And you can see there's other neurons connecting with it through these little foot-like processes. But then all this information coming into this particular cell is now going to go out down one of these processes that we call axons. So this is kind of a fairly typical neuron within the brain, in the cortex of the brain, or within these nuclei located within the brain. Now, the rest of the brain is actually made up of all these neural pathways or tracks. And we often refer to these cell bodies, particularly in the cerebral cortex as the gray matter. And then where these cells are passing and connecting with each other, we often call the white matter. So you can see here in this diagram, we've got the gray matter and this outer layer of the cortex, and then all the inside of the brain is going to be white matter, which is really these pathways that help these neurons connect with each other. Now we have other neurons in the brain that are not really neurons per se, but are called microglia. So these are specialized neurons that actually provide structural integrity to the brain. And it's about 5 different classifications of these microglia within the brain. And these are very specialized cells. Some of them provide structure. This is actually one cell that forms what is called the blood-brain barrier, which prevents a lot of toxins from getting into the brain. So this is protecting the blood vessels and stopping any bad stuff from seeping into the brain and damaging the brain. And then there's other kinds of little cells like these microglia that we're not entirely sure what they do. But there's one Professor Trombley, Dr. Trombley at UVic, that's actually studying these microglia and finding that they seem to be related to things like dementia. And they're finding that these change in shape and color and texture as we age, and this could have a negative impact and particularly produce some of those neurodegenerative diseases that we'll probably be talking about a little bit more. So there are these neurons that are essentially communicating with each other, and there are other neurons that are providing structural integrity to the brain and the brain matter. And some of them are there for protection. Some of them are actually part of the immune system, and they float around the brain looking for any bacteria or any kind of pathogen that gets in and basically breaking it down and destroying it. So, we're not just talking about neurons in the brain, we're talking about how they connect and how they communicate. And, this is what we'd call a typical neuron. So this is the body, and you can see all these processes that are connecting with other neurons. So this is information coming into this part of the neuron. And then once that information is collected and it reaches a certain threshold, this neuron will fire. And when it fires, it will actually transmit the impulse down this particular process. Now, in the brain, they're not going to be super long, but this could, in fact, be a process that goes from the brain to your little toe. So they can, in fact, be huge in length once they're out of the brain and the spinal cord and into the peripheral nervous system. So this is an electrical impulse that passes down. Now, it's these most of these processes or axons are wrapped in this fatty cell, and that's called myelination. And this just allows the conduction of that electrical impulse to jump rather than passing all the way through. It'll pop its way down and increase the speed of transmission. Now, the key thing here that we're going to talk about is once that electrical impulse is reaching the end of this axon process, you can see it has a terminal point here. And this is filled with what are called these little synaptic vesicles. Now, you've probably heard of neurotransmitters, and this is where these neurotransmitters are located. So as that electrical impulse comes down the axon, it'll change the permeability, and these particular transmitters will be released into a gap that exists between this neuron and the next neuron. So as you can see here, this particular branch of the axon is going to many more other neurons, and each one of these endpoints, or the synaptic knobs as they're called, is now going to release a chemical or a neurotransmitter, and that will then send the electrical impulse down the next neuron to go to what is called its target place, right? So we've got a succession here of connection between electrical impulse causes release of a neurotransmitter or a chemical, and that will then change the permeability on the next neuron, and that will convey that message down to the next level. So, this is really an aside rather than, part of this particular lecture, but here is a neuron connecting with another neuron, and that's essentially what we've been talking about before. But remember, neurons drive everything within the body. So neurons can, in fact, connect to what we'll call skeletal muscle. So like your biceps or your quadriceps muscles, they're all innervated by neurons. And again, the electrical impulse comes down, there's a chemical transmission, and then that will cause a change within the tissue that is distal to that. And in this case, it'll cause the skeletal muscles to contract. Now, in addition to going to things like target organs and muscle, these neurons can in fact stimulate glands and other kinds of parts of tissues within the body. So the neuron is functioning in a very similar way. It has an electrical impulse that causes the discharge of the neurotransmitters, and that will have an effect or an effect on the next tissue or organ, often called an effector organ. So we won't get kind of too much into that tonight, but I love this kind of diagram because what we're looking at here is this neuron, and these are other endpoints of other neurons connecting to the cell body of a particular neuron. So all these ends of other neurons are sending information into the cell body, and based on the collective of this input, we'll decide whether the threshold is reached, and therefore whether that impulse now is communicated to the next neuron. And you might kind of think, well, why am I getting into all this detail? Well, I hope it'll make more sense to you as we get into the next part of this particular presentation. Before we do that, however, I'm just kind of showing you a cross-section of the brain. So this could be, the left hemisphere. This is the right hemisphere, depending on whether we're looking at the front or the back. Hard to really tell in this particular diagram, but we're looking at a cross-section. So this is the middle part of the brain. So this would be the right hemisphere or the left hemisphere, and that would be the other hemisphere. Now, this is the cortex that I was telling you about. It's this very thin, less than ½ an inch thickness that surrounds the outside of the brain where all those cell bodies are located. These are the nuclei that we've spoken about as being centered through in the brain, performing rather special functions, and I'll touch on them in a few slides ahead. But what I'm showing here are these lines, which are in fact the pathways by which parts of the brain communicate. So we have the upper part of the brain communicating with cells in the lower part of the brain. And then we have others that are going to go across the brain so that one hemisphere can in fact communicate with the other hemisphere. So in most people, we have a left and a right hemisphere, and we have these fibers that go across from one hemisphere to the other that allow cells in each side of the brain to actually connect and talk to each other. And you'll see I've got a little slide inside set up here that says, except for the real Rain Man. And I don't know whether you remember the Rain Man movie, but this was actually based on a real life person named Kim Peek. And they maintained when they did sort of MRIs that his brain was not really two hemispheres, but really had a single hemisphere. And he had some amazing abilities. And it was said that he could read 2 pages simultaneously, with the left eye reading the left page and the right eye the right page in a matter of seconds. Then he could tell you anything that had happened within that book. He could read a book within minutes and tell you everything that went on within it. So kind of an interesting aside there. Of course, Dustin Hoffman played the Rain Man, or he played Kim Peeks in the movie. And then, of course, we have Tom Cruise over here that was taking advantage of that in his gambling, all right, because he could actually read the cards. Unfortunately, Kim Peek was pretty incapable of looking after himself. So although he had this amazing ability, referred to now as a mega savant, then he was unable to do some basic functional stuff and very dependent upon his father throughout his life. But, having said that, this is again showing these little projections or the ways the brain communicates from left to right, from up to down. And this upper diagram is showing you how the brain can communicate from the back to the front and the front to the back, and then other places down. So these are those fibers of the white matter, or these long processes that go between neurons that allow neurons to connect and communicate with each other. So you'll hear the term often like, neural pathways, or establishing neural pathways, as we do in learning. So the stronger we develop these pathways, then the more predictable that particular pattern or behavior or memory will be. We're not getting into the different names of these particular projection fibers, but these are the ways in which the brain and the cells within the brain connect and talk to each other. I did say I'd mention very briefly here that throughout the brain, so this is the brain again, a cross-sectional area looking from the front to the back of the brain, and we can see right in the middle of the brain, we have these collections of cell bodies, which are called nuclei. And in this particular case, we're looking at the basal nuclei. So this is a cross-section of the brain. This is a small segment from it. This is that segment blown up. So we have all these different specialized parts of the brain that are dealing with very special kinds of functions. And just as a general statement, I'm going to say these basal ganglia in general are responsible for motor control, voluntary motor control. That's like me saying, well, I want to pick up this particular object, then that's me telling my body what to do. Procedural learning, eye movement, and even cognitive and emotional functions. So, these particular basal nuclei are associated with very specific kinds of functions. Anyway, the other part of the brain I'm going to mention here, because it's very important when it comes to the effects of physical activity on the brain, is an area called the hippocampus. So right here, we've got the hippocampus, and we can see that it's just a small part of the brain, and it performs a very special function because most memory is actually momentarily held here before it's passed to the cortex for more long-term memory. So if the hippocampus doesn't function very well, then it has a very negative impact upon memory. Okay, so that's a little bit of background. What can we do now to help our brain, keep healthy and keep it doing the things that we want it to do as we get older? I'm not going to go through all these. I have other presentations where I talk about, all these different things that we possibly have an impact on the brain, but I will just focus on a couple of them. And three in particular: genetics, a little bit about brain games, and then a little bit about nutrition. So the first part here is that we can't ignore genetics, and certainly genetics play a kind of an important role when it comes to this thing called neurogenesis. That is, how well can we reproduce these neurons in the brain, and how well can we have them connect and talk to each other? So this is a little cartoon that says, eat less, exercise more, and invent a time machine so you can go back and choose the parents with better genetics. At times we think, oh, well, if I was going to live this long, I've taken better care of myself, or maybe I'd have chosen better parents. So that's one particular thing. And of course, there's no doubt that genes are passed from one generation to another. And here's an example through Mr. Beam as a baby, as a mother, and also as a father. So genetics certainly play a role. They play a role in most things that happen to us as we age throughout life, and neurogenesis is no exception. However, there are things like a gene that makes people more susceptible to various kinds of brain diseases, such as dementia and Alzheimer's. So you can have a gene that means you are at greater risk than others, although we know that other than one particular disease, that gene still has to be turned on. We're not sure what turns these genes on or off, but you may have the gene, you may never actually have that particular disease, even though you have perhaps a higher predisposition to getting that particular thing. So that's just by way of that. Now, in regard to nutrition, I could spend a lot of time talking about the different foods that are supposed to be the super foods for our brain health. But by the time I kind of get through all that, the bottom line is that currently we don't have a huge amount of evidence to confirm the relationship between the food we eat and cognitive function. So that's kind of looking at all the research that is currently available, saying, well, what is the magic food? What is the food that's likely to increase brain health? Maybe omega-3 looks very promising, but currently it's not to say that there's no relationship there, because I'm sure there is. It's just that the evidence we have is not terribly conclusive at the moment. Of course, another thing that we're often told to do for our brain and keeping them healthy is to keep them active. And we do that by playing different kinds of games. So we can think about jigsaw puzzles and crosswords, and of course, Lumosity, which is one of the recent crazes, and now we've got Wordle. So there's a lot of ways that we can try to challenge the brain to keep it working. And the belief is that if we do that, then the brain will will stay healthy for longer, and in fact, we may enhance its particular function. And again, it's not to say that these games don't work. There's some evidence that suggests they do. But right now, the research that's been done is not particularly compelling. What often happens is you actually get better at playing the game. The question is, does that really improve our brain function? And again, that kind of connection between the game and functionality is not as well established as we would like it to be, but it really may be a fact that the research just has not yet been done. However, the one thing I want to focus on tonight is that the number one way to boost brain power is through physical activity. Now, that must come as a big surprise, right? I think there's been a lot of research done over the years where, if I was to say the research is very strong, I would say it was in this area. In the other areas I've touched on, the research is there, but it's not as compelling as the amount of research that's been done looking at the relationship between physical activity or exercise and brain function, particularly our brains as they age. Okay, now I kind of flip-flop between physical activity and exercise. And I don't necessarily like to use the term exercise because it implies, kind of formally taking on some physical activity. So I kind of like the term physical activity because it includes everything from walking to gardening to housework. It's just getting the body to move, and to move in not necessarily a vigorous way, but in a way that at least it's moving and it's going through some fairly kind of active work, be what it may. So, where am I coming from on this? Well, it obviously us in the exercise field have a little bit of a vested interest in this kind of connection, but it's not just those of us in the field that are saying that physical activity is very important in regard to brain function. So this was going back a few years now when Stu McDonald, who is again a cognitive aging psychologist at UVic, was asked by a reporter, what's the most important thing we can do to slow cognitive aging? And his quick response was physical activity. He said it's associated with a decreased risk of cognitive decline and diseases like Alzheimer's. So that's a very generic statement, and we can look a little bit more into what is meant by that. In addition to that, the World Health Organization says exercise, not pills, is the best way to prevent dementia. This is a kind of a more recent quotation, and these kind of data would say people can reduce their risk of dementia by getting regular physical activity, then all these other lifestyle issues that we think are pretty self-evident. But that's one that I highlight in the context of this particular presentation. So, there's obviously a connection here from what some people say about physical activity and the brain. And you're kind of, well, what is that connection? How does that affect health? And I hope now that the introduction that I made and giving you a bit of insight into how the brain works will now make more sense in regard to how physical activity can, in fact, impact brain health. There's a kind of direct means here, which is obviously if we get more blood flow to the brain, we reduce the risk of stroke, and we keep the brain healthy as a tissue because it's receiving the nutrition and the oxygen that it needs to function. We can reduce some of the sugar effects. Inflammation, I won't go into it now, but it's one of those things that tends to cause breakdown in tissue. But this is kind of an important point here to say it actually will increase the release of growth factors. So chemicals in the brain that affect the health of brain cells. There are other kind of hormones that are going to be released that increase or help the development of new blood vessels in the brain. So, there's a thing called VEGH, which is vascular endothelial growth factor, that when you exercise, it increases its production, and that actually helps the blood vessels in the brain to grow. And of course, the more blood flow we have to the brain, then the better it is for the brain. And even the abundance and survival of new brain cells. Well, a lot of this will be repetitive as we go through these next few slides. And again, there's an increase in the volume. One of the things that happens as we age is the brain will shrink. And if it shrinks, then it obviously starts to lose some function. And there are certain areas of the brain, such as the frontal cortex, hippocampus, and the temporal cortex that are kind of important in terms of brain function. So if we can maintain the size of these particular structures, we tend to increase their effectiveness. And then I'm going to talk a little bit more about physical changes that take place in the neurons. And this is work done through Brian Christie's lab, where they found that there's physical changes in those neurons that help the neurons communicate better with each other. And there's another hormone released here that's associated with the cognitive function called irisin. And again, that's something that Brian Christie's students and his research program have looked at and found some very interesting connections between that and diet, but also physical exercise. So we'll touch on a few of those as we go. Now, there are some indirect effects, and these are very much connected to brain health. We obviously need to have enough sleep. If we don't sleep enough, then that's not healthy for our brain. If we live with too much stress and anxiety, that's not very healthy for our brain. So physical activity has been found to improve mood state, improve sleep and deep sleep, and of course to reduce stress and anxiety. So if we have problems in any of these areas, they're likely to be detrimental to brain function and cause some kind of impairment in how our brain works. There's a bunch of slides I'll show now, and I'll try not to spend too long on these because I want to get to the more practical side of this particular presentation. So here they're just using PE for physical exercise, determines positive biological, psychological effects that affect the brain, cognitive function, and you can read this as well as I can, and promote this idea of well-being. So we know that through physical activity, we do get enhanced mood state. And we know that when we exercise or we're physically active, the brain releases these endorphins and enkephalins, which are the brain's opiates that give the sense of well-being and improve mood state. However, we know that this recent evidence has shown that there are very powerful hormones or I'm going to say transmitters, but they're not always in the form of transmitters. They are hormones that produce neurotransmitters that are also mediated through physical activity. And it can, in fact, cause a permanent alteration in gene expression. So these are kind of powerful effects of physical activity. This is another thing that I plucked from another reference here, which says that exercise and circulation BDNF mechanisms release implications for the design of exercise intervention. So this PDNF stands for brain-derived neurotrophic factor. And these act on certain neurons in the brain, central nervous system, as well as the peripheral nervous system. And they help support the survival of the neurons that we have. And it also encourages the growth and differentiation of neurons, new neurons, and synapses. It's well established, according to this research article, that acute exercise increases these circulating levels. So again, that's another direct response of physical activity on their brain function. And again, there's a growing body of literature, as it says here, that talks about both the long-term and the short-term effects of physical activity. Now, this is aerobic activity. I'll talk a little bit more about resistance training, and that it can achieve similar benefits. And basically what it's saying is that these things that happen can improve cognitive abilities and enhance mood. And again, this is a fairly significant review done in 2018. If you read one article, and you really want to gain an insight into the effects of physical activity on the brain and mood and everything else, this is the one article I would recommend to you. It is full of good stuff. And it kind of breaks it down into talking a little bit about the behavioral effects. In this case, we're talking about one single bout of exercise. So we're talking like 15 to 20 minutes of physical activity. And most of what I'll share with you now is not talking about the acute effects, that is doing physical activity on a daily basis, but just doing it once. And some of the positive effects you can realize from 10 to 20 minutes of being physically active. So we've talked a little bit about some of these enhanced mood states and decreasing stress levels. This also talks about cognitive function. So executive functions are higher functions of the brain, such as computational skills and problem solving and things like that. And it says here one of the most dramatic effects is the change in these neurochemical levels and these neurotransmitters, these growth factors and these modulators, both in the brain. That's what I was talking about before, that what happens when these neurons connect is they can do it electrically, but at some point they need to release these neurotransmitters in order for these neurons to connect and talk to each other effectively. And again, I'm going back to a diagram I showed before because this is some of the work out of, again, Brian Christie's lab, which I'm fascinated to see. And this is one of those axon processes, right? In this case, it's a dendrite, which is one of the fibers leading to the brain. And what is happening here, to the cell. And what is happening here is it actually develops what are called these spines. So these are the spines that develop. And what it does is allows other neurons to connect more effectively to a particular neuron. So these are physical changes that take place in the dendrites of the neurons, these fibrous processes that connect other cells to a neuron. And they are permanent changes, and they are enhanced through physical activity. I just found that quite fascinating. So Brian deals very much with molecular changes that are taking place in the nervous system through other kinds of interventions, of which physical activity is one. Okay, so let's get to the crux of this matter. What are the activities that have been found to be very helpful? And there are many. And I'll kind of review these again at the end. But this is what got me interested in this whole thing, going back probably 10 or more years now, where I saw in the paper, and this was actually the Times columnist, but they'd actually taken it from the Globe and Mail in 2010. And the headline was, "Boosting your brain power could be as easy as a walk in the park." I kind of think, where do they get that from? What is the basis of them making that rather, extravagant claim? So I started digging to where the source of that information came from. And it turned out that it was a number of studies that was done by this professor at the University of Pittsburgh named Kirk Erickson. And what he did is he followed nearly 300 seniors for 9 years, and he monitored how far they walked in a week. And he did different measures of their brain. One was an MRI, which measured the size of the brain. Now, remember, I said the brain shrinks with age, and that's associated with memory problems and dementia. And he did some cognitive tests looking for cognitive function and or memory loss or dementia. And what he found, people who walked 6 to 9 miles a week, or 9.7 to 14K, had less brain shrinkage, cut the risk of developing cognitive problems by 50%. That's a pretty powerful result from a fairly minimal commitment to physical activity. He did other studies where, again, he looked at exercises and non-exercises. He looked for them walking around tracks, and he did this for 12 months, and these people did it 3 days a week for 40 minutes. Others just did stretching and some weights. And what he found is the people that were exercising increased the hippocampus volume. Now, remember I said before that that is a very important part of the brain for memory, and particularly transferring short-term memory to long-term memory. So if that is compromised, then it will impact long-term memory. And again, the exercise group improved memory and also spatial navigation. So again, pretty powerful stuff. I kind of took this from the Ontario Brain Institute, where they actually reviewed 900 studies over the last 50 years that looked at physical activity and things like Alzheimer's and dementia. And the conclusion in reviewing all these studies that if you just take brisk walks, 10-minute bouts a few times a day can significantly delay the onset of dementia and even prevent it. Regular physical activity also helps people with Alzheimer's and other forms of dementia better manage their condition. So again, pretty valuable source there with the Ontario Brain Institute based upon a pretty comprehensive review of the available information. And this is a bit more coming out recently, where again it talks about regular physical activity gets the heart and your sweat glands pumping, but it appears to boost the size of the hippocampus. Brisk walking for 1 hour is associated with an increase in the volume of selected brain regions. So all these very positive connections. Now, running or jogging, here's a little Herman cartoon for you that says you must have run a mile this time. You've been gone 4 minutes. So if I use that with UVic students these days, first of all, they wouldn't know what a mile was, and they certainly wouldn't know the significance of running it in 4 minutes. I think most of us probably watching tonight do. Anyway, I won't talk about those particular running groups. But here, this is again another study in JAMA that found that aerobic activity 4 times a week, which was running on a treadmill, an elliptical running machine or a stationary cycle, reversed the decline in cognitive ability and memory, especially true for women. So tons of stuff that was done. This was a study that was actually done looking at dancing, and came out, again, headline from the Times columnist, "Dance Your Way to Healthier, Happier Living." And what they found that people who engage regularly in dancing improve balance and gait, reduce factors associated with falls, but in the context of tonight's presentation, reduction in dementia, and again, here's these terms, attributed to neuroplasticity and the rewiring or the connection of these neurons. So here we go, dancing. So, what kind of dancing? Well, I think it could be any form of dancing. There's line dancing, Scottish dancing, you name it. My wife loves all these kinds of physical activities, whatever takes your fancy. I've tried to talk to her into actually trying pole dancing, dirty dancing, and haven't had any success in that regard. There was a study done 2 years ago in England that didn't have any formal dance training as part of their intervention program. They just put people in a gym, put music on, and let them just dance around to the heart's content. And again, they did pre-post measures in terms of cognitive functioning and brain health, and they found these people showed drastic improvements in their cognitive ability. So dancing, combining a little bit of brain activity as well as physical activity. There are other ways of exercising. And these studies have used cycloergometers. I'll talk about one particular study in a minute, about rowing ergometers. All these machines that get the muscles to work. Why? Because when muscles are active and contract, they actually release these neurotrophic hormones that are then released into the bloodstream, which work their way up to the brain and then help these neurotransmitters develop within the brain. In addition to that, during physical activity, the brain will also begin to produce its own neurotransmitters. So very powerful prophylactic form of maintaining or increasing brain function as we get older. And I know some of us have balance issues and joint issues doing various forms of activity. So this kind of activity works well. And I keep wanting to include a slide on water exercise, because again, that would achieve the same kinds of effects. I'm sure somebody will ask me questions on that later. Anyway, this is, I kind of throw this in, but I'm often said, what's the best exercise machine? Well, it turns out the best exercise machine is taking your dog for a walk. I know around here, I don't know where you live, but I can't believe the number of increase in dog walkers that's happened since COVID. I think there's companionship, but the beautiful thing about a dog is that it's forced exercise program. You have to go out and exercise at least 3 times a day, whether you want to or not. So there's a prof at UVic in exercise science that's looked at the fitness levels of dog walkers and compared them to non-dog walkers. And he's found, some very significant health benefits to people who own dogs and therefore have to walk them. All right, now, I don't always get into this, but I will tonight talk a little bit about the intensity. Most of what I've spoken about so far is kind of walking and doing, aerobic activity, which is generally of a kind of what we'd call moderate physical activity level. That is something that you can sustain and maybe do that for 15, 20 minutes, even up to an hour. So you're getting a little bit stressed, but you're not out of breath, and you can probably converse with somebody that you're walking or exercising with. And I'm going to talk a little bit now about intense physical activity. And I'll kind of warn you up front that it's not for everybody. for a number of reasons. One, it's not very pleasant to do strenuous exercise. I kind of like it myself, but that's just me. But it's not necessarily a kind of a go for a nice gentle walk or jog. This is really exercising hard and pushing the envelope. However, people who were over 71 who did this kind of exercise were more mentally nimble and had better memory function than people who were sedentary, and they followed this group over a 5-year period. So intense physical activity does seem to have a kind of very positive effect on cognitive function and brain health. This was a kind of a study that was done that looked at what they call forced exercise on an improvement in Parkinson's disease, and particularly motor function. And the evidence suggested that patients with Parkinson's got a lot of benefit from doing the exercise. And they said that the intense exercise triggered the release of neurotrophic. There's those terms that I'm talking about again, neurotrophic factors that possibly help the production of dopamine. And we know that basically Parkinson's is the result of the lack of production of this neurotransmitter called dopamine. And you can have drugs to replace it, but they're not very effective and they lose efficacy over time. But physical activity was found to be particularly helpful in this regard. How do they do that with somebody with Parkinson's? How do you get them to work hard? Well, this is a tandem bike. And they have basically the person setting the pace in the front, and then they have the patient behind. So this person is forced to work harder than maybe they would through their own volition. There are other programs that have looked at this, although I haven't seen the research evidence, such as Boxercise. I know in Vancouver, and I think in Victoria, we have one program for people with Parkinson's that are in fact doing Boxercise and finding some significant results. And I thought I would share this with you, which is a bit of a video, and I hope the video works, on how powerful, what a great prophylactic effect exercise can have on neural conditions, particularly of the brain.
1 million Americans have Parkinson's. Another 50,000 are diagnosed every year. Sharon Alfonsi now on the case in today's New England Journal of Medicine, which astounded the experts.
It was so amazing, the doctor shot video of it. This Parkinson's patient struggling to walk, even falling down at one point. But he swore he could ride a bike, so they took him to the parking lot, and off he went, pedaling perfectly, even executing a U-turn.
This gives Parkinson's patients throughout the world reason to be optimistic.
But how can you go from this 1 minute to this the next? Dr. Jay Albert's been studying the effects of pedaling on Parkinson's after his own amazing discovery. Alberts, an avid cyclist, went on a 50-mile tandem bike ride with a friend who had Parkinson's. In this video shot before the ride, his friend's hand shook wildly, but afterwards, steady. So Albert started a trial at the Cleveland Clinic. Parkinson's patients pushed to pedal hard.
10 minutes, a little harder, I'll get your heart rate up.
The result? An improvement in motor functions that lasted for weeks.
I haven't had any meds yet today, and I was shaking pretty good. But this exercise, it's amazing.
Researchers still don't know why it works. One theory, pedaling releases chemicals that improves motor function. The same theory behind this. Parkinson's patients able to dance.
This is a transporting exercise. When I come here, I don't have Parkinson's.
For patients, intriguing mysteries that could put a new spin on treating their disease. Sure.
Okay, so I think to me that's a bit anecdotal in a way. I haven't seen the research coming out on that yet, but it sounds like it's very promising. However, this was a study that was done and published in in a Canadian journal here, where they looked at 64 sedentary seniors, trained them for 12 weeks. They had 3 groups: a high intensity stretching group and moderate intensity. They found the high intensity group had 30% improvement in memory, and particularly high interference memory. So again, there seems to be something about the intensity of working out that produces some pretty significant effect in people, particularly those who have some kind of neurodegenerative condition. So what is this HIIT? Well, again, the warning that I would put out to you is that it's not for everybody because it's not pleasant. But secondly, if you do have any cardiovascular problems, then you may be working at an intensity that puts you at some kind of increased risk. If you've had heart conditions and you put on a cardiac rehab program, they'll often put you on an exercise stress test, and they'll find out the level that you can exercise at safely. Because if you get above a certain intensity, usually 85 to 90%, then you can start throwing different kinds of arrhythmias that obviously could be pretty risky. So if you are going to try any of this, then obviously I'd always put the caveat out there that says, please check with your medical professional if you have one or can find one to make sure that working at a high intensity is actually safe for you to do so, particularly if we're a bit older. Now, there are a number of ways you can do that. What this high intensity work usually involves is a full, almost maximal effort for a short period of time, followed with an active rest, and then you repeat that for a number of periods. So, there's this particular McMaster group here. Their protocol is usually doing 10 maximal 60 seconds of work with 60 seconds of active recovery. So that's 20 minutes. And, you can break that down in a number of different ways. This one here, the 8 maximum efforts of 20 seconds with 10 seconds of active recovery, in other words, total time of 4 minutes, was one of the original studies done by a man named Tabata, who was a Japanese physiologist, who found that this kind of program was as effective as 60 minutes of moderate walking in terms of increasing cardiovascular or aerobic fitness. This one I've highlighted, which talks about maximal efforts of 4 minutes with 3 minutes active recovery, was specifically looking at changes in brain health and found this to be a very effective form of high intensity training. And there are other combinations of this. These kinds of training programs or exercise programs have been done with a variety of populations, including those with various cardiovascular conditions and other conditions such as diabetes and obesity. And they've even done it with cardiac transplant patients 12 months after transplant. So again, it's not for everybody, but it is being done more and more with an older demographic. And the general feeling is that it produces equal or better fitness and health outcomes, including mental health, compared to longer duration type of activity. So I just thought I would share that with you. And I'm going to finish here talking a little bit about weight training. And again, there was a study that was done by a UBC grad a few years back now and then subsequently published in the Archives of Internal Medicine, where she looked at resistance training. In this case, it was with women, and found that after 12 months of once or twice weekly resistance training, that they improved cognitive function and increased walking speed and looked at the reduction in falls. So again, resistance exercise has been found to be another form of physical activity that helps with brain changes, especially in particular parts of the brain and executive function. So I know I'm running a bit out late here and out of time, so I want to wrap this up fairly quickly. It doesn't have to be going to the gym and working out with weights. I use these TheraBands a lot. As John mentioned in the beginning, I run a men's fitness class, and we use the TheraBands, and it's a very effective form of resistance training. Again, this just when I thought I had this thing sorted out, I came across this journal that was full of articles related to old age dementia. And what they kind of concluded was that there's no magic bullet in the fight against old age dementia. And this was a group called the Minnesota Evidence-Based Practice Center. And they concluded that cognitive training, these brain games, has not been shown to definitely work. Neither have medications or over-the-counter dietary supplements. And here they go, nor a single exercise regimen, which I found was a bit of a downer. However, I was kind of uplifted a little bit by the editor of this particular journal, who wrote his own little paper at the conclusion saying that common sense actions throughout life may help to avoid or delay Alzheimer's and related dementias. Obviously not smoking, but Number one, engaging in regular physical activity. Then he talks about controlling diabetes, hypertension, cholesterol, and weight, because all these things are actually controlled through physical activity. And I do other presentations where I talk about the connection between diabetes, hypertension, and cholesterol and physical activity. So we know that this plays an important role in controlling these other conditions that they mentioned. So here's the take-home message that the recommendation is that for all of us, minimally, we should get 30 minutes of moderate physical activity, basically 5 times per week. And, that is going to be 30 minutes, basically, of 5 days a week, which gives you 150 minutes. Minimally, 3, which would give you 90. More is better. Or if you want to be more vigorous, they found that studies where 20 minutes of physical activity 3 times per week will actually give you the same effect as doing 30 minutes of moderate. And of course, the other caveat here is to talk a little bit about, the intensity. Again, you can be more intense, which means that you're actually spending less time being physically active. And the other recommendation, for a number of reasons, is to try to incorporate at least twice a week some form of resistance training. So there we have it. All these things may have a positive impact on our brain, but the one that I feel is most compelling is physical activity. So there we go. So what do you like to do? That's the key. You've got to find something you like to do. Table tennis, again, a big study in England found that playing table tennis with seniors improved their cognition and improved their memory. Of course, the big rage right now here is pickleball, but finding something that you enjoy doing is one of the keys to actually sustaining it. And I'm not going to go through these tonight because I don't have time. So I'll just go right to the end and say thank you very much for listening. It's just about an hour up, a bit longer than I anticipated, but that's par for the course, I think, with me. And I'm certainly happy to entertain any questions or comments you may like to fire my way. So thank you. Over to you, John.
Oh, Dave, thank you so much. That was
You've fallen asleep.
Not at all. That was an excellent presentation, timely, significant, and useful, and fully accessible. So thank you so much for that. It was really good. Some of the questions that have come up. One is, you're talking about the benefits of physical activity. Now, how would a regular old person such as myself doing this monitor effects? Like on brain health. Is there any way to do that?
That's a very good question, actually, and I don't really have a very good answer to that, John. Yeah, I think it's basically just on your daily living and trying to monitor. Do you feel better? Is your mood increased? That's kind of all subjective. Am I forgetting things less? So we all forget stuff. There's no doubt that as we get older, we do forget. And you've probably heard the old story. You go into a room and you go, why did I come in here, right? So I say, it happened to me the other day, and I was glad I remembered in time because it was the bathroom. So, if we just kind of, decrease, the times when we're forgetting stuff, then that's another subjective way, a general feeling of well-being. And, for general health and wellness, just having more energy and finding things that once were difficult, you now find easier. With my men's fitness group, I do a lot of, squatting in and out of a chair. And basically, you doing daily functional activities should become easier once you engage in regular physical activity. In terms of mental health, certainly mood state would be one that would generally most people could feel and notice. And the other one would be, do I remember things? Am I solving problems easier? But I don't have any definitive simple test that anybody could do to say, oh, well, this has really helped me do this. I'm sorry. I don't have anything like that unless somebody out there, has something that they're aware of and would like to share with us.
Yeah, well, it could be a good area for research and application, I would think.
Yeah,
I mean, you got all these exercise machines, but I mean, monitoring overall, brain health and things like that, it'd be, I mean, for us seniors, it'd be really quite valuable.
Yeah, well, obviously, medical profession and psychology, they have, specialized tests that they could use, but I don't know of anything that, like simple as say taking your blood pressure would give you some indication of the effects of exercise on cardiovascular health. But I don't know any simple test of brain function.
Yeah. Here's a question that came in. Of course, it started off with a great thank you for your presentation. You indicated there's a relationship between intensity and duration for improvement. Is there any data on the relationship for different decades? For example, like the 60s versus the 70s versus the 80-year-olds?
Yeah, I haven't seen, comparisons of 60-year-olds to 70 or 80 to 90. But, a lot of these studies are actually done on people who are older than 70. Right. So if you look at the age group of the different studies, the 70, 75, particularly with resistance training, and even some of these higher intensity exercises. So I don't think chronological age is necessarily a good indicator of exercise tolerance. And again, this is more subjective than anything else. But in my men's fitness class, for example, I have many that are late 70s and a few into their 80s. And I am kind of there myself in October, right? And my main form of physical activity is high intensity work, mostly because I do it on a stationary bike, and it's so boring to ride a bike for 30 minutes that I find going hard and then easy, going hard and easy helps me pass the time. So I don't think higher intensity work is necessarily chronologically age related. And an 80-year-old can be very fit. I've got an 83-year-old friend, and he's still hiking in the Alps and doing just incredibly difficult treks, 10, 12, 15K a day in the mountains. I mean, to me, age, chronological age is not a strong indicator as how you are faring. And that, could be genetic for sure, but there's also lifestyle things that are going to be implicated in that, I think.
Another one that's come in, what are the major differences that research has found regarding exercise for women versus men? I mean,
another excellent question. Well, you'll have seen a lot of the studies that I quoted actually just used women. Yeah, and so they didn't really compare women with men. It was just like with women, this is what we found, and we didn't compare whether women did better or less well than men, and so on. So most of these studies, I haven't seen a gender comparison or a sex comparison, I guess is the correct term. But physiologically, I think that the responses are going to be very, very similar. But I haven't seen the comparative studies that would really allow me to be definitive in that regard.
But would you suspect there's like significant differences, or the patterns would remain more or less the same?
I would think the physiological changes and the changes in the brain would be very much the same. I mean, I don't see physiologically or anatomically why they would be that different. There is some data now that implies women's brains and men's brains are slightly different in regard to how they're built, and particularly the connections between the neurons. But I don't know whether they would respond differently to physical activity. I haven't seen that.
Yeah. Another question refers, you were talking about neurogenesis early in the presentation, and there's a question about like rates of neurogenesis, because you'd assume that the rate's going to be higher for younger people than older people. Would that be the case?
Well, it certainly would be the case early on in life. When you're looking at a child as they're growing, their brain is growing and the number of neurons are just increasing exponentially. And then we reach kind of maturity, and then the number of brain cells stay pretty much the same. The question is, whether or not through physical activity, whether you would be able to generate more neurons younger than you are when you're older. And I would suspect, like with everything else, that if you're younger, you're going to respond better. You're dealing with healthy cells, and cells obviously, they have to develop out of stem cells, and we know that younger stem cells are better than older stem cells. We know that through a lot of research, that the efficacy of a younger stem cell is going to be much greater than an older stem cell. So when they're talking a little bit about replacing stem cells, they like to use stem cells from younger people rather than extract them from older people. So if I was going to have stem cells, I'd rather have somebody who's younger than take them out of my hip and putting old stem cells in, because they just do not duplicate. We know over time, as cells replicate, then they lose their efficacy and they become less functional. So I haven't seen the data on it, but looking at the way we age and biological aging, I don't think there's any doubt that neurogenesis is going to be a lot more active in younger people than older people. I mean, I think the good news is that it still happens with older people. To what degree, in terms of measurement, 10%, 50%, I haven't seen specific data. A lot of the data that they produce really is looking at behavior. So they're doing cognition tests, they're looking at memory tests, and of course they are doing some biological testing, physiological testing, and extraction of hormones, right? But that's not actually measuring, the number of cells that are being produced. I don't know how they would do that. I don't think too many people would volunteer for a brain biopsy while they're still alive, right? Which is probably the only way you could probably do it. I'm still amazed. How do they know there's 100 billion cells in the brain? Does somebody actually count them?
You've been pretty positive about physical activity, which makes a lot of sense given the data. But are there any downsides to this?
Downsides to physical activity in regard to brain health?
Yeah.
I mean, you're asking the wrong person, I guess. I don't see any, in terms of how it could possibly be. I mean, what we're doing is decreasing risk, and you're going to decrease the risk of strokes. And I would say that's one of the major threats to brain health. And we know there's different kinds of strokes. It probably won't decrease the risk of a bleed, but it will probably decrease the risk of blockage. So it'll decrease risk of stroke. Would it increase that? Well, I guess there's the potential. If there's a blood clot and being physically active forces it to be released and it moves its way around and lodges in the brain, I guess there could potentially be a risk of that happening. We know that sometimes when people who've not engaged in physical activity do so vigorously, then they can put themselves at risk again, through heart attack. And again, it's more the idea of having clots that are embedded somewhere being released and then blocking some essential component, whether it's the brain or the heart. So I think there's always a risk of that happening, through physical activity. So again, if you look at every book that has physical activity, they always say, before engaging on physical activity, check with your medical professional that it is safe for you to do so, because, clearly there are some risks involved and they can be rather drastic and somewhat fatal. But, again, the recommendation is always you start these things slowly. If you've not done much before, start slow and build slow. Don't try up here and go hard when you've done nothing for 20 years or so. So, it's small increments, 10% a week or so, adding on to distance or, intensity is probably the general recommendation. And again, it's mostly through safety. The musculoskeletal things that can happen will repair, but things like heart attacks and strokes are not easily repaired. So again, I think you should always err on the side of caution. Yes, there is risk in regard to physical activity, particularly going from sedentary to something, but the risks are diminished if you take it slowly and build it up over time. And it's no kind of probably secret to you, I know, and to a lot of people out there, that despite all my commitment to physical activity all my life and what I thought was sensible, well, reasonably sensible eating and, generally a healthy lifestyle, I had a heart attack 3 years ago. Now, the fact was that I didn't even know I had it, right? I just had tightness, but sure enough, I had it. And the comment from the cardiologist was, well, it's unfortunate and a bit unfair, but by the same token, if you hadn't had the life you'd had, you wouldn't be here today, and you wouldn't survive as you did, and you wouldn't have recovered as well as you did. So, physical activity is no panacea. It's no guarantee that bad things won't happen. However, it actually improves the outcome. But again, take it easy, cautiously, build it up over time. And, if there are contraindications, like if you've had a cardiac event, or you have some kind of atrial fibrillation, and you have some precondition of arrhythmia, then you need to be careful engaging in high intensity physical activity. Again, a lot of us, as we get older, are on medications. We're on beta blockers, we're on blood pressure medications. And if you go exercising hard when you're on those medications, sometimes everything's dampened. And then you lose blood flow to the brain, you get dizzy, and then you kind of pass out and faint. So again, be cautious. You know your situation. Have you been physically active or not? Are you on medications? Do you have any predisposed medical condition? And you do need to be wary of all those things before engaging in a particularly a vigorous physical activity program. Going out for a walk, which will be as much physical activity as most of us need for benefit, should put you at zero or no risk, right?
Okay,
I don't know whether that answered the question, but anyway, it was a good one.
Yeah, no, I mean, the benefits far outweigh the risks.
I think so.
You've got optional approaches to it.
Yeah.
But I would like to take this opportunity to once again thank you for a most engaging presentation with actionable outcomes. I know for me, and I'm sure most of the audience as well. So thank you very much. It was a great presentation.
Thanks, John. Most appreciated.
Okay, and before we leave, next week, we have another Masterminds presentation entitled The Unstoppable Rise of Artificial Intelligence. Should We Be Worried? By Hugh Cartwright. So that's next Wednesday, 7 o'clock. Look forward to seeing you. And once again, thank you, Dave. And thanks for the audience for participating.